Okay, so this week's demo lab, you need open the General Social Survey 2022 data set and codebook, as well as the syntax file. Okay, so I have those. So next, it says, what is a ratio or ratio-like variable in GSS that you think might have a relationship with theism? Name the variable and write a research question between them. Okay, so I need to look for a ratio or ratio-like variable that I'm interested in. So it can't be categorical unless it has at least, unless it's like ordinal and it has at least 5 categories that seem equally spaced. I could use age. You could use degree. Let's use this one, friend fam. So this one says, well, some people think that close relatives should be the most important people in one's life. Others think that it should be close friends who are the most important. Which view is your opinion from 1 to 7? So we have this scale here, like 4 would be they're equally important. 1 is relative, so family, and 7 is friends. And so I'm curious to see if there's a relationship between the extent to which you believe in God and whether you think family or friends is more important. So it says name the variable. So my variable is friend fam. And then write a research question. Do people who prioritize family versus friends, um, let's see, are people, well, it's a US adults who prioritize family versus friends more theistic? Which one's more theistic? That's our question. Okay. A hypothesis. What would I think? I'm thinking that, well, people who are more theistic might have more traditional views of family, and so maybe they'll be more likely to prioritize family over friends. I'm not sure. So I'm going to say that I think, but I don't really know if there's a huge connection. So I'm going to say I think there is a weak relationship. Um, I think it will be, so do I think it's going to be sizable? Mhm. I'm going to say no. Maybe it will. That would be interesting. I do not think it will be substantive. And then it says direction. So for direction, I mean, what I'm saying is that family is going to have higher theism, but let's take this variable. This is as this goes up, that means that we're getting closer to friends. So as the IV goes up, that's like more prioritizing friends. And if we look at theism, as theism goes up, that's more theism, right? Like that's believing in God. Um, okay, so since I'm saying that as you're more likely to prioritize friends, you're less likely to believe in God. So I'm saying that as the IV goes up, the DV goes down. So I'm going to say it's a negative relationship, meaning, right, that um, more prioritization of family equals more theism, right? Or in this case, right? So more prioritization of friends is um, less theism. Okay, so I've made my kind of guesses, and then we get to find out later. So it says using SPSS, find the minimum and maximum for both variables. Share your syntax here as well as the output with the minimum and maximum variables values. And this is more for later to help us with graphing, just to see the whole span of it. Now, I'm guessing that there's going to be people at least at all of the kind of ends of this, but we'll see. So I'm gonna just make sure my syntax commands show up in the log. And right, I could also do that by going edit options, viewer, make sure this is checked and click OK. And then here's my, this is going to generate my minimum maximum. You see where it says no table means there's no frequency table. So I'm just going to put in theism and I'm going to put in friend fam and click play. The other thing I could do is analyze descriptives frequencies. And when I'm in this box, I'm going to go to that statistics window and say, okay, I want my minimum and my maximum. And click continue. It doesn't matter if you have the tables. I'm turning the tables off. I don't need them. And I need to find my two variables here. So friend, fam, and theism. And then I just click OK. So let me copy my syntax. And let me copy my min and max for each. Oh, I had a copy this time. Nope, that was ugly. I can paste special as image. There we go. So I didn't have to take a screenshot because it let me copy and paste it. But you see when I paste it, it didn't look good. So I right clicked and clicked paste special and chose an image, and that let me do it, or a picture. Okay, so we can see that the theism one goes 1 to 6, the friend fam goes 1 to 7. Okay, now we're going to turn on weighting, run a linear regression test, share syntax, and provide two of the outputs that we get. So we can see here's my weight by weight variable name. We know that the weight variable name here is weight variable for this data set. We've been using it all semester. I could also go edit, data, weight cases. And then I could find my weight variable, weight cases by, put it in, and click OK. Okay, and then I want to run my regression. So here's my regression syntax where it says DV name, that's the dependent variable, which for us is theism. And then for the IV, that's the friend fam one is what I had chosen. So I'm going to put those in. That's my independent variable, my dependent variable, and just click play. Oh, that did not work. Let's see what's going on. Okay, so when I look here, I can see friend fam. There's a lot of missing data here. Here's one that has data. And then if I look at theism, you can see that one that has data does not have data here. And there's some missing data here too. So I went to the GSS Data Explorer, and you can see that for theism, it was asked on ballots B and C in 2022. Right? You can see in 2018, they asked everybody, but here they just asked 2 out of 3 of the ballots there. And then for friends or family, it's ballot A. So ballot A were asked about this, and ballots B and C were asked about this. So we don't have any respondents in common that were asked about both. And so that's why we're getting an error there, because actually we can't compare the relationship because we don't have people who answered both. So we have to go back to the drawing board and choose a different variable that is going to be ratio like to test for this. All right. Well, we know everybody's age in here. That was asked to everybody. So let's just go back to age. So I'm gonna let's see. I need to rerun this one. So I have the minimum and maximum for age. So age goes from 18 to 89, where 89 is 89 plus. Let's copy this. No. And I'm using age. So does theism differ by age is my research question. And I think that there is going to be a moderate positive relationship, moderate positive moderately substantive, somewhat substantive relationship. Meaning I think as age increases, theism is going to increase. So older people are going to believe in God more than younger people. I think that there's going to be variation, right? Like we all know people of the same age have different beliefs about God. But I do think that it's going to increase steep enough that we're going to see different beliefs between young people, middle-aged people, and old people, for example. Okay. So now we're going to run this regression. And instead of friend fam, I'm going to use age. Great, that worked. Okay. So what do I need to put in here? First, how do I do this with drop-down menus? I could go analyze, regression, linear, and then my dependent variable is going to be theism, and my independent variable is age. And let's see, in statistics, I want to have my descriptives, I want to have my confidence intervals, I want my covariance matrix. I don't need any plots. Don't need anything there. Okay, so I'm going to click OK. So let me put in my syntax. And then it wanted the correlations and the coefficients one. So the correlations, this one right here, that's the one I had to go in and click and say I wanted the correlations matrix. Otherwise, it wouldn't have given it to me in the drop-down menu. I already have it set up in the syntax. So I'm going to copy and paste that as an image. And then I want the coefficients one, which is the bottom. Oops, right here. That one I can't copy. I'll take a screenshot. All right. What is the value of your correlation coefficient R? So I don't want you to look right here because this one is an R that, like, when we get to multivariate regression with multiple independent variables, we'll use for strength. But this is always positive. This is always the absolute value because you could have different independent variables, some negative, some positive, etc. And to know the direction and the actual value for a bivariate, we need to look back at that correlation matrix. In this case, they're the same because it's positive, but if this was negative, this would still be positive here. So in this correlations table, I'm looking and I see that the Pearson correlation, right, for age and theism is 0.192. Okay, so what is the strength? So for this, I'm going to go to the textbook to chapter 10. And you'll remember that it goes from right 0 to the absolute value of, right, well, so -1 or 1, where 0 is no relationship and 1 is a perfect relationship. And so here we have 0.192, which is going to be here. So we have a weak relationship, right? Which means, again, that, like, there's a lot of variation, right? It's not great for making predictions. There is an observable pattern, but it's not a great fit. And then the direction, right? This is a positive number, so it is positive, which means that my prediction is right as age increases, theism views increase. We were wrong on this. I thought it was moderate. And then it says explain it in context. So this is the same thing we did last week. So I'm going to take this template. And I'm going to take that template for direction, although again, I don't need the target populations. It's already in there. Okay, so there is a weak relationship between age and theism. So it's my independent and my dependent variable. Well, there is an overall observable trend among US adults in 2022 that as age increases, theism increases, right? It's positive. So as X goes up, Y goes up. That's how they're covariant. There is substantial variability. We can only make weak predictions of theism for US adults in the sample based on knowing their age. So our predictions will still be overall more accurate than if we ignored age entirely. Okay, now I need to write my linear regression. So this is where I'm going to go to this coefficients box right here, and I'm going to look at this column where it says B, and my constant is going to be y-intercept, and then this is going to be my slope. So my linear regression equation is y equals a plus bx, and I leave the y and I leave the x. Y is my dependent variable, x is my independent variable. For a, I'm going to put in the value of the constant where it says on standardized coefficient b. So that's 3.799. Just going to round to the nearest hundredth. And then for the b here, I'm going to put in the slope. So that's this column and my variable age. So 0.018. Also around that. I'm going to keep though it unrounded for graphing, just might as well just put in more specific numbers. There. Okay. So this is my equation. So now it says graph it using Excel, provide a copy of the graph and a screenshot of the top. So to do that, I'm going to actually go to chapter 11 and I'm going to download and open the template there. So you'll see there's this bivariate linear regression graph template that talks about how to use it. And so you're going to want to download this and open it. Okay, so I opened it. So first I'm going to replace these two cells with the intercept and slope. So my intercept A was 3.8, well, 3.799, I'm just going to put in. And my slope B was the 0.018. And then this is, remember, we already found our minimum and maximum. And so it says replace this for the minimum maximum for an independent variable, which was age. So for age, that was 18 and 89. Okay, and so now I've made my graph, but it doesn't look good. So first it says replace the x-axis label with the label for my independent variable. So this is going to be age. Then I'm going to replace this one with theism. And, I'm going to also just add to that so I know exactly what this scale is. That theism is 1, atheism to 6. Theism without doubt. And why don't I just say that age is in years? We know that 89 actually means 89 plus, but that's okay. Okay, so now it says edit the minimum and maximum bounds for the x-axis to go at least from my minimum through my maximum. So this in age, right? We don't have any data from 0 to 18. This is all adults. Oh, so we have starting at 18. We don't have anything 0 through 17. So that's why there's nothing here. And then this is only going to 25-year-olds, but we know this goes to 89. So I'm going to double click on here, and over here, I'm going to click on this kind of bar graph, axis options, and I want this to go, so if it's going 1889, I want it to go, I'm going to say to at least 90. And then I'm going to just have it start at 15. I'm not going to do 18 to 89 because it's going to, if I do that, you'll see it kind of has weird numbers for the jump. So I'm going to just go 15 to 90. And then I can leave this alone if I want. That's kind of the increments. You can see if I change that to like the major units of 10, it goes up by 10s. I'm going to put it back at 5, so I didn't mind that. You can see this, I could say, oh, I only want like 1 in between, so I want it to go up by 2.5s each. Could even have the whole thing go up by 2.5s. You can see that's hard to see. I might have to adjust the size of that or the positionality of it. But I'm just going to go back to 5 and 1 because I think that's fine. Okay, so now this is looking better. However, we're not quite done. So if we look at our dependent variable axis, the y-axis, it goes from 0 to 25. But if you remember, right, theism doesn't go from 0 to 25. Actually, it says right here, it goes from 1 to 6. And we also know from our calculations that there are people all the way at 1 and 6. So I could choose to use the minimum maximum bounds of like where people could actually be, or I can choose to use kind of where of where people actually are in terms of what respondents did or what their choices are. So like if I had a feelings thermometer that went 0 to 100 and everybody was between 50 and 100, I might want to just show 50 to 100, or I could just show 0 to 100, right? And I could still have that kind of scale and we just see where folks were. So anyway, I want to replace this. So I'm going to click on here and I want this to go from 1 to 6. And then you'll see I only see a 1 and 6 because it says the major unit is 5. So 1 plus 5 is 6. So I want to show each of the 1 through 6s. So I'm going to change that to 1. And so now we have each. And then let's just add some, I'm going to add, I put in 0.25. So that means like a quarter. So I'm just adding these little marks in between as well. Okay, so now I have my graph and it looks much better. So I need to put in here a couple things. So to show my work, I'm putting in this top part. So I'm just going to take a screenshot to show what I put in. And that way also, right, like if for your independent lab, if you do your graph wrong, I can figure out what happened. And then here I'm going to put this in. I'm going to take a screenshot of this as well. And there we go. Okay, it says explain your y-intercept in real life context. Tell its story. So if I'm in chapter 11 and we're talking about the y-intercept, here's the template and examples. And so this one would be, I would predict that, right, like the individual US adult respondents who are a 0, so who are 0 years old, right? So newborns would be at a, what was the y-intercept? 3.8 would be at a 3.8. So let's go and look at theism. So that's above higher power, almost at sometimes believing in God. Would be um just short of sometimes believing in God. Now, this doesn't make a lot of sense for us. Because uh, our age starts at 18. So we don't actually know what kids think, let alone newborns don't have any ideas about what their theistic beliefs are, right? And so what I would actually say here is that this, because our independent variable starts at 18, the y-intercept cannot be interpreted using real life context. However, mathematically, it's suggesting that we would predict that a 0-year-old would be at a 3.8. So you can see on this graph that right, we're predicting that 18-year-old is around here. So if you carried this down until you got to 0, right, that's where the y-axis would meet with 0, then that's where it would be. You will have that for feeling thermometer ones because your feeling thermometer will go to 0. So we would be making predictions for somebody who's very cold. Oh, sorry, that's your dependent variable. It depends on what you choose for your independent variable. If you choose another feeling thermometer, you'd have a 0. If we ended up choosing something on here, let's see. Nope, so these go 1 to 7. So this is one reason I like to read code tabs. So here it would be like making a prediction for a strong Democrat if we had used party ID. Okay. Now we're going to explain our slope in context. So here's our slope information. Here's our template. Okay. So again, our slope was 0.018. So we're saying on average, every one IV unit label. So for each unit increase in our independent variable, which is age, it's a year, right? That's what that means. So if it was like income, it might be thousands of dollars, right? If you're using feelings thermometer, it would be degree. So each year increase in, right, a respondent, oops, I'm an individual, a respondent's age. So I can say that, but I think that's a little clunky. So I'm just going to reword that and say every 1 year older that a respondent every 1 year older mm, for a respondent is associated with an increase. So it's always an increase of 0.18, but if it was like, oh, sorry, 0.018, but let's say that a slope was like -3, instead of saying an increase of -3, we just say a decrease of 3, right? So it doesn't make a lot of sense to say an increase of a negative number. Instead, we'll just do decrease of the absolute value. But for here, we're just doing an increase of 0.018. And it's going to be units in theism. So this is a little bit harder, right? If this was something like income, we might be able to say like in this many thousands of dollars in income, right? However, for this one, this is hard to interpret very easily, right? And so what we're going to have to do for this, since it's not kind of something that's relatable to real life, this scale, is we're just going to clarify for the reader that theism is on a scale of 1 atheism to 6 theism without doubts. And that way you can kind of get a sense of what 0.02 is on that. Okay, so based on your, so then actually I'm going to do the second part of that. So I want to scale up because this seems super small. When I see this, I'm like, oh, 0.02 units, this is definitely not substantive, but I need to say whether it seems sizable. So one thing I might want to do, I mean, I could actually just look at the graph here to kind of try and tell. But um, instead, what I might do here is say, okay, how about like every decade or every 25 years or something? So why don't we say every 20 years older? So I'm going to say similarly, every 20 years older for a respondent is associated with a, and so instead of a 0.02 unit increase in theism, it's going to be that times 20. So that would be like almost half a unit increase. And so we can then think about, okay, now it's starting to seem a little more substantive because, right, every 20 years you're going up by about 0.4. So over 40 years, you're going up by 0.8, right? 60 years, you're going up by 1.2. And so now we're seeing that there's actually a change as you get older, whereas for here, it seems like there's not much. So does it seem sizable? As the independent variable goes up, does it seem sizable? And I'm going to say yes to this because, right, it's not like it's just above a 4 and then it's still just above a 4, like 4.5, right? It's going from 4 for the younger adults to over a 5 for older adults. Um, and similarly, we can see from the slope that, right, as you're getting older, right, it ends up being more than a unit, which again, a unit's not much depending on the context. Like if we were doing a feelings thermometer from 0 to 100 and it went up by 1 degree or even 2 degrees, like that's barely anything. But again, this is a scale just from 1 to 6. So we're saying it's going from younger folks having sometimes believing to older folks being above having doubts to like between doubts and no doubts, just above kind of the, so they're unlike, they're not as likely to have doubts, they're above the 5 on average. So I'm going to say yes, it seems sizable and meaningful to me. While young people are just above a 4, which is sometimes believing in God. Our oldest respondents are, right, predicted to be above a 5, which is above sometimes having, or which is above having doubts. This is a different theism category out of only 6 categories. Okay, so I could do that. I can refer to this slope. Again, if this was something like income, I might say, that like um as let's say my dependent variable is income, I might say, somebody who's 20 years older is predicted to make $30,000 more. That's a lot of money, right? So I can kind of do different things there. All right, what is the p-value for the slope? So I'm going to look at this coefficients and I'm looking at the slope. So the age row, here's my slope, 0.018. And this p-value is the sig column, and I'm looking here. And this one's telling me whether I'm confident that this is actually different from 0, right? Because 0 would be a flat line as opposed to going up, it would be flat. And we can see here that we're 95% confident our slope is somewhere between 0.014 and 0.022. So we're 95% confident it's not 0. In fact, we're over 99.9% confident, right, that it's not 0. So what we're going to say here is P is less than 0.001. And I got that from right here. Is there a statistically significant relationship? Yes. P is less than 0.001, which is less than 0.05. Right, so if P is less than 0.05, then we're saying it's significant. And what does that mean? That means I am over 99.9% confident. I got that from 100% minus 0.01%. That there is a relationship among my target population, among US adults in 2022, between age and theism. Let's see if we can use that friends fam one with hours worked last week. Maybe those will have ones in common. Okay, yeah, so we can do that. So here what we can see is that the correlation coefficient is negative 0.009. So it's a very weak, negligible to non-existent relationship. It's negative, meaning as we get closer to, I think it was friends as it increases, then we get lower in our theism, but it's close to no relationship. And then we can see in our coefficients one that our equation would be y equals 40.29 plus negative 0.08x. And if we interpreted our y-intercept, right, we would say that, let me go to friend fam. So this starts at 1. So again, this should not be interpreted. If this was a 0, it would be interpretable. But basically, we're saying like they think family is the best sport, but they're above thinking it definitely should. Like they are like super into, right? If we extended this line further, there's somebody who is like so adamant that family should come over friends as more important, would be predicted to be at a 40.3 in terms of the hours they worked last week. And then this is saying for every unit increase. So when we go from a 1 to a 2, 2 to a 3, 3 to 4, 4 to 5, 5 to 6, 5 to 7. So every unit going from thinking family is more important towards friends being more important. For each of those, somebody's working 0.08 fewer hours on average. Okay, if we were to graph this, so here I would put in 40.29 and negative 0.08. The minimum and maximum is going to be for friend fam, so 1 to 7. And then I need to edit these. So this is going to be family to friends, more important. And so instead of 15 to 90, I want this to be 1 to 7 with a major unit of 1. Marks. And then this is going to be hours worked last week. And I didn't, let's just look at the minimum and maximum for that. Goes 0 to 89. All right, we can put that in. Let's see. So let's do 0 to 90 first. And we can see, again, it's very little movement. That's because our slope is so close to 0. So I'm just going to actually zoom in on, say, 35 to 55. 35 to 45 is what I meant. Because it's around the 40. Okay, so there's my graph. So we can see this one's not very substantive, but we can see that, again, the y-intercept would be if this went to 0, where it would be. Like super if thinking family is important over friends. And then our slope is saying for every 1 unit increase in this, it's going down by barely like however many minutes of having worked last week. And we're seeing it goes from like 40 and a quarter to almost 40 from people who are at 1.7, so not very different.